today after our past couple of lessons? What do you guys see that's been missing? The equals sign, right? We're back to solving. Now, what do you notice about these two problems? They're the same. I know. That was kind of hard to notice, but they're the same, and I know they're the same. Now, my Math 1050 class today, this is what we reviewed in their chapter 1, and half of my class liked method 1, half of my class liked method 2. So that's why I teach both methods every year, and then with our class, I usually go with the majority, so we'll kind of have to see what that is over time. If I ever help you individually and you tell me you like one over the other, I'll use that one with you every time, okay? So it's all about solving for x, and the first one wants us to, method 1, we're going to say work with fractions. Work with fractions is method 1. All right. What do you think we're going to have to do to that denominator right there? We're going to need to factor it. So I need two numbers that multiply to be -8, add to be 2.
4 and 2.
4 and -2. At least you didn't have to use the rainbow method, right?
I didn't even know that. That's what it was called.
I don't know if that's like its universal term, but it's a phrase that a lot of teachers use. I'll have to come up with what it is. Let me put parentheses around that while we're here, and that while we're here. Now over here on the right-hand side of the equation, it says to add those two fractions together, doesn't it? So what do I need to do to add fractions together? What do I have to have? Common denominator. So this one happens to be missing, what does it need?
X minus 2.
All right, so if I multiply the x minus 2, can you guys see why we practiced this for so many days now? If I multiply if I multiply the bottom by x minus 2, I have to multiply the top by x minus 2. All right, so let's clean this up then. I've got 1 over x minus 2 equals, there is my common denominator. And over here, I've got a 2x minus 4. I don't want to rewrite this every time, so just doing a little work right there. So I have 2x plus 2x, which is 4x. And I have 1 plus a -4. Now I have a fraction equals a fraction. A proportion equals a proportion. We haven't done anything this ugly, but isn't the easiest way to solve when we have a fraction equals a fraction to cross multiply? So let's see, I'm going to put parentheses around that so I remember it's together. And now I have 4x minus 3 times x minus 2 equals x plus 4 times x minus 2 times the 1, but I don't need to put that, do I? Questions thus far? All right. What's my next step? I'm going to end up with x squareds, right? So this is a quadratic equation. I'm going to need to set this equal to 0, which means I need to FOIL out both sides. So there is 4x squared minus 8x minus 3x. Don't let me make a mistake, please. Oh, please, oh, please. X squared Now, if you're not a person who can do outside, inside in your head, I chose not to over here, but I was going to point out, I didn't even think about this one because didn't I have it up here? Just pointing out some little secret shortcuts, okay? Save yourself some work. I don't know about you guys, but I like to have my x squared positive. So I'm going to choose to move everything over to the left-hand side when I set this equal to 0. So I've got 4x squared minus 1x squared, which would be 3x squared. Gone, gone. Right here, that's a negative 11x. Take away 2x would be negative 13x. So gone, gone, gone. And then I will have 6 plus 8. So I have a quadratic equation that you can choose to factor, if it will factor, or use the quadratic formula. What would you guys rather? All right. I don't even know if it factors. Let's find out. Are there two numbers that multiply to be, what is that? 28, 42?
7 and 6, negative 7.
But add to be negative 13. 7 and 6. Negative and negative? All right, so negative 6, negative 7. So I'll rewrite this. 3x squared minus 6x minus 7x. Did you ever think there was going to be one problem that used like every algebra tool that you've learned over the years? Huh, here it is, right? Split it down the middle. Greatest common factor would be 3x, x minus 2. Greatest common factor on the right, 7, because the negative, we're going to put negative 7, x minus 2. So this factors 2, x minus 2, times 3x minus 7. Okay, we factored. I'm slowing up. I see a lot of people taking notes, so I'm stalling for a second. What are my, now listen to this key word here. What are my possible solutions? What makes this one equal 0? 2. What makes this one equal 0? Add 7, divide by 3, right? 7/3. You type those into your homework and it says try again. Because my operative word a second ago was what? Possible solutions. So because this has, come back to my original up here, because this has a denominator in a variable in the denominator, let me rephrase that. There are values that would make my denominator equal 0. Remember, we can't divide by 0, right? So x couldn't be 2, or x couldn't be negative 4. What do I have down here?
2.
I have a 2, so 2 is a bad answer. I have to throw that one out. But 7/3 works. What do you think? How'd you feel about that one?
It's easier than yesterday's one.
It's easier than yesterday's work. Okay. I always like having a goal, like solving for x. It makes it feel easier to me, even if it's messier for some reason, because I feel like I've accomplished something maybe. Method 2. When I name this one, we'll see how you guys react to it. Let's find a different color. That starts to work good. Get rid of fractions. Who's thinking they're already going to like that one better? All right. Now, I want you to know, I picked the ugliest problem, one of the ugliest problems I could find. We had pretty answers, right? I didn't get ugly quadratic formula answers. But I picked one of the most challenging problems I could find. And you're going to do the hardest problems today. And then tomorrow when we practice this and I add the easier problems, you'll actually probably get more stuck on the easier problems than the harder problems. Kind of did that on purpose because then you're ready for all of them. Same thing. I would factor this. X plus 4, x minus 2. Get rid of fractions. Now, what I want to do is I want to look at the denominators all the way across the whole equation, left-hand side and right-hand side. And I want to find their least common multiple. I hesitate to call it a common denominator because we're not adding or subtracting fractions here. But I want to find the least common multiple of all three denominators in this case. So I would need x minus 2, right? This is just me thinking over here. And I would also need x plus 4, right? That is my least common multiple of my denominators. Now remember, if I do something on one side and I do it to the other side of an equation, it's fair game, right? So if I times this side by my least common multiple, now I could choose, don't write this down, so I'm going to show you what I'm doing. I could choose to write it like this, and then have to distribute it through. Or I'm just going to write it right now with it distributed through. So I'm going to times this by x minus 2, x plus 4. I'm also going to times this by x minus 2, x plus 4. I'm going to put the over 1, the over 1. Some of you won't need to see that. Some of you like to see it. Now remember, we can, when we're multiplying fractions, we can cross-cancel diagonally as well as up and down, right? So that's where this is our friend. Watch this. X minus 2 cancels with x minus 2. Let's move over to the first fraction on the right-hand side. X plus 4, x plus 4, x minus 2, x minus 2. Some of you will get to where you do this in your head and set it up. X plus 4 cancels with x plus 4. So let's see what we're left with. I'm left with x plus 4 times 1. Do I need to put the times 1? No. Equals, whoo, everything canceled right there. So I'm left with the 2x plus 1. Now over here it wasn't quite as friendly, but I am left with what? Plus 2 times x minus 2. Wow, this is feeling a lot nicer. All right, let's clean it up. Take away x, add 3. So x equals what? Huh. Did I get the exact same answer? Now, in all honesty, this problem ended up being a lot friendlier. It just did. That's not always the case. In this problem, yes. They are both equally acceptable, equally challenging at times, or easier at times. It just kind of flip-flops. So what you need to decide is, would I rather combine the fractions and then cross-multiply, or would I rather get rid of fractions? So I'm just curious, and you don't have to commit, but how are you feeling right now? Who would rather work with fractions? Get rid of fractions. Okay, so that's how we'll talk about it from now on. So what is the secret to get rid of fractions? Find your least common multiple, multiply every term across your equation, cancel and solve. Let's see where you go. You guys are like, getting in my homework. We don't need another example, Mrs. Yates.